Okay, so we're recording now. So lab tomorrow, that'll be done online. Lectures 5 and 6, those are on the pages, and you'll just listen to those. Then we've got a little bit of a break. On Monday the 17th, that's Martin Luther King Day. And then on the 18th, which is again a Tuesday, I've got a Soil Horizons assignment that'll show up, or maybe it's already there. I don't know, but same kind of deal. It's going to be available from the 18th at 8 a.m. until the 18th at midnight. And there's a description on there what to do. Then on the 19th, that's when we're going to have our first quiz. It's a pop quiz that you guys already know about. So look for that to show up. Also that day, I've got a video for lecture 7 that's up already. And then on the 20th, we're going to have lecture 8. So I'll post all that on the announcements, and we can kind of work from there. And then on the 24th, I'll be back, and we'll kind of get back into the live swing of things. Okay. Did you guys run into anything from lecture 3 that you want to talk about? I can't even remember what was on lecture 3. I guess I can look here real quick.
Horizons.
Yes. Horizons. Everything made perfect sense. Let me.
I got a question about like the letterings that they have, like the Horizon O and all those other ones. Are those like the same basic ones, or are they all like different kind?
What do you mean? Are they all the?
Like are they like the ones that are like organic, and like as they go down, and like it's like the rockier one? I forgot how it is. I have it written down in the notes.
Yeah. So typically, let me share my screen here. You guys see that okay? I'll assume so, because no one said anything. So O Horizon, that's only going to exist in like a organic type, think of like a forest floor or the tundra that Jordan was telling us about up in Alaska, where you don't necessarily have like a mineral soil. It's all organic. And so you don't necessarily have to have an O Horizon. You don't necessarily have to have an E Horizon, but you typically have A, Bs, Cs, and it depends on how deep you go.
Do we have an O Horizon here in the basin?
Nope. There is no such thing as an O Horizon in the basin. You've got to go into the mountains like the rainforest in Western Washington. So like in the Olympics and stuff, you'll find O Horizons out there, but absolutely not around here. Yeah. Man, I keep getting these calls today, and I just want to throw my phone out the window. I'm sure it's spam. Okay, yeah, and then if you look at these subordinate horizons, just pay attention. These are the kind of the big ones that we talked about, and it's just a matter of memorizing what A and B and F means. So anyway, we've got the assignment on the 18th is going to be you putting into practice these master horizons, these subordinate horizons, looking at a profile and using those to name it. So I wish you good luck with that. All right, lecture 4. Let's look at lecture 4 here. Okay, this is where we get into classification. So we've talked about horizonation and stuff. This is where we're going to start to talk about giving these things other names other than A, B, AA, AP, things like that. We're going to name them. And just out of professional courtesy, these are not my pictures. They came from a guy from U of I. So anyway, they're fantastic pictures. This guy has like the, I don't know, the quintessential library of soil horizons in the US. So I'm going to use a lot of his photos. Okay, so soil taxonomy, this is our system for naming soils. It's an organized system. We have our system in the US. There's also an FAO system, and I think that's like an international one. But, you know, in the US, we're better than everywhere else. So we're going to use the US system and ignore other countries. But, you know, just to, you know, so you know that there are other systems of classification out there. In my profession, I run into this FAO one a little bit, but very, very little. And in the US, you know, we tend to stick to our own thing, and it makes sense to me. So that's the one that we're going to talk about. Okay, it is based on soil horizon properties. It has a Midwestern bias because most of the soil scientists in the world live in the Midwest. And so, you know, they take their particular slant on things, and everyone else is like, okay, there's so many of you that we can't argue. And so it has a little bit of a Midwestern bias. You know, there is some notion that the whole system is being rethought. And I've been showing this slide for, I don't know, 8, 10 years, and it hasn't changed. So I think it's going to take like a massive undertaking to like retrain everyone in a different system. And I don't know that it's ever going to happen. It would take a lot to redo the whole system that we use. Okay. And oh man, I didn't sleep well last night. There are 12 soil orders. And just looking at these names, what's something that is common with all of them you guys see? What do you think, Jessica?
They all end in OLS.
Yep, they all end in OLS. And that's basically like a shortened way of saying soil, okay? And I've put this one up here on its own for a reason. These other ones are typical mineral soils. A histosol is an organic soil, okay? These are the ones that are going to have that O horizon that Freddie was asking about earlier. So a histosol is not actually a mineral soil, it's an organic one. These other ones are mineral. And the first, you know, 3 or 4 letters of these, maybe 5, it tells us a little bit about what kind of soil we're dealing with, okay? And we're going to talk about every one of these, but just remember that this hist, that tells us that it's an organic soil. This ent tells us that it's an entisol. And I'll give you some examples. So when we say something is histic, I don't know, if you look up histic in the dictionary, it's probably going to tell you that it's organic in nature, okay? Entisols is kind of a play on the word recent. Okay, so these are very young, newly formed soils. Inceptisols, also, when you think of Inception, have you guys ever seen that movie Inception? You need to watch it. It'll blow your mind. But inceptisols are a lot less entertaining than that. Also Inception, right? That tells us a little bit that these are also very young, newly formed soils. They're different than entisols, but I think we differentiate these two by these ones are recent, these ones are actually brand new. Okay. Aridosols, this one's easy, right? Because we all know what arid means. These are soils that exist in areas where there's very little rainfall. Okay, a gelisol. This one is actually like tundra. It's a frozen soil. And so we say when the soil's frozen, it turns into a gel. So that's how I remember this one is a gelisol. Andisols. Andic, what could that mean? What's that mountain range that runs north and south
It's
through
like a South American soil or soil base.
Like the Andes.
like the Andes, yeah. So you guys are on the right track. These are actually volcanic soils. So I guess the Andes were formed from volcanoes. Maybe not so much, but that's what they called them. So remember that an andesol is a soil formed in a volcanic type of system. Vertisols, these ones are interesting. We'll talk about them. We're going to talk about all these in detail, but vertisols are formed from vertical cracking, and you kind of get a mixing, and you know, the top becomes the bottom, and the bottom becomes, you kind of get this mixing up and down of a vertisol. Alpha sols, we find these often in temperate forest type locations. And I've got a good way to remember this one. I'll tell you in a minute. A spodosol, this one exists in a rainforest or a foresty type situation. And the interesting thing about a spodosol is that it usually has an overlying O horizon. Okay, so this is not a histosol, but because we've got that overlying organic horizon and then we've got mineral soil below that, that's what makes it a spodosol. Okay, a mollisol, this is kind of a prairie grassland type soil. We see these often in the Midwest, so like, you know, the Dakotas into Kansas, Nebraska, where we have that, the grassland, that's a mollisol. Also, the Palouse soils are mollic. An oxisol, this is a highly weathered soil. So usually we only see these in like rainforest and stuff. And we end up getting, have you ever like seen like a picture of the rainforest and the soils are kind of a bright red or an orange color? They do that because of the iron and aluminum oxides that are in there. And so that's how it gets its name as an oxide. And then an ultisol is a highly weathered soil. Okay, the clays have broken down, very wet, sometimes very humid. And so this is basically what we consider a very highly weathered soil. Let me show you how some of these look if you were to look at their horizons, okay? You will remember that an entisol is brand new, okay? Very recently formed. And so what you see here in this entisol is we've got a C. Do you get what does C stand for? Let's maybe do a little bit of review here. Who can pipe up and tell us what C stands for? I'm going to call on someone. Adil, what do you think? She's looking at her notes, turning pages. Or maybe she's just gone to the restroom or something.
No, I'm here. I just haven't found it yet.
Okay, that's fine. Manish, do you remember?
Associated with the soil or the clay particles?
Not quite.
No.
So C, this is our unconsolidated parent material. So this is the rocky, cobbly stuff. And then you'll see that at the top, we've got a very small skiff of A horizon, which is topsoil, right? Okay. So the weathering, you know, it's just a very small amount of weathering that's creating this topsoil. So that's an entisol, very recently formed. All right. A vertisol, what could I say about a vertisol? I want you to pay attention to this clay percentage right here. It's saying that a vertisol has about 50% clay. That's a lot, okay? The other thing to pay attention to is organic matter. You'll see that we've got quite a bit of organic matter towards the top, and as we move down to the bottom, it becomes less. So we've got nice horizon development with A horizon up here, but it all kind of meshes into A1, A2, and A3. And basically what that means is this is all A, it's topsoil, but there's just something about them that we have to designate them as 1, 2, and 3. Maybe the color is a little bit different. Maybe the clay content's a little bit different. Maybe the organic matter is a little bit different. They haven't really specified, other than we know that organic matter kind of tails off as we move down the profile. So I'll show you a better example of a fertisol in a minute. Okay, an aridisol. Look at this right here, organic matter. In an arid climate, what do we expect the organic matter to be, high or low?
Lower.
Low.
Yep, very low. So limited plant growth, low organic matter, but we've got, you know, some horizon development. Okay, so over time, this thing's weathered down, and we get an A and an AB, which is kind of a A mixed with a B. We get the BT. You guys remember what BT stands for? Okay, the T stands for an argillic horizon. So that's an accumulation of clay particles. So we've got this accumulation of clay down here. Anyway, good example of an aridisol, lack of organic matter. Okay, an inceptisol is kind of like an entisol, but this is a little bit older, and I may have misspoken before. This is the newest soil. This is also very new, but now we've already got some B horizon that's developing. So that's an inceptisol. Ultisol, you'll remember, is ultimate, that's last. So this thing's highly weathered. We end up having A and E horizon. The thing I want you to pay attention to here is this this base status. So not a lot of bases in here, very low bases. And that tells us a lot about, so the bases are the calcium, magnesium, potassium, and sodium. And in an ultisol, all those get washed out of the profile and end up being very low. So anyway, ultisol, very highly weathered. Oxisol, this is something that has a lot of iron and aluminum oxides in it. So check out this iron number. As we move down the profile, the iron starts to jump up. We get this O horizon, which is an indication of oxides. And so we've probably got some pretty colors here, probably a red or an orange type of hue. Okay, spodosol. Remember, the spodosol exists in like a forest. So we've got this O horizon up here. The neat thing about a spodosol is that in this O horizon, we've got organic matter, but there's so much rain that it'll wash through there, and it'll take some of the organic acids out of the O horizon. And once we get acids that leach into this mineral portion, it'll kind of wash them down through the profile. And so a lot of the times it's E horizon, which is a zone of eluviation that starts with an E. And what that means is that we've got things moving out of the profile and down into another one. Where else did we have an E? We had an E in this ultisol, right? So again, a zone of eluviation. We've got, in this case, we've got clay particles moving from this zone and they're depositing down here. Same thing happens in a spodosol, but in this case, we've got S. What does that stand for? You guys remember? I have to relearn this every year. Let me pull my book out. Oh, look at that. S is an alluvial accumulation of organic matter, iron, and aluminum oxides. So some of the iron and aluminum oxides that are existing up here in this E horizon, the organic acids are causing them to solubilize and then leach down to the lower profiles. So spodosols are actually very interesting to look at, and we will in just a minute. Okay, alpha sols. Man, usually in this class, we end up getting some older students that are like my age. Do you guys know who Alf is? The TV show Alf?
Is that like the alien puppet thingy?
Wow, I'm impressed, Freddie. Let's take a little field trip here. for a second. Can you see my Google screen here?
No.
No.
Okay. I don't know why it does that. I've got two monitors in my office, so can you see it now?
Yeah.
Okay. All right, Alf. This is an old TV show, and this is the main character. It's this guy named Alf. And look at it. He's got some nice orange and brown coloration to him. ALF stands for alien life form. So he lived with his families, and his deal is he likes to eat cats. Isn't that hilarious? Anyway, this is how I remember what an alpha sol is. It's usually found in a temperate forest. So think maybe like Northern California, where it's not super wet, and we get soils that are a little bit drier, and we get this coloration where we've got these browns, darker browns, maybe into the orange hue a little bit. So that's what an alpha sol is. Okay. Can you see the slides?
Yes.
Well, you can't now because I just killed it. Ding it. All right. Alpha sol. So yeah, the thing I like to point out again is over here, these are like the color. We're going to talk about color in some more detail another day, but the color really is the giveaway. And also you can look at organic matter. So again, a forest soil, but organic matter only tops out at about 2.5%, and then it dies after that. So lower rainfall, but foresty type soils, alpha sol. Okay, mollisols. These are cool to look at because they've been growing grasses for eons, and you get this nice, deep, thick A horizon of topsoil with a decent amount of organic matter. And then as you move down the profile, we might get some translocation of clay particles. That's what the BT is, right? Subsoil accumulation of clay particles. Look at the clay content as you move down. It goes from like a 20 up to maybe like a 30, 35. And then we get into parent material after that. So mollisols, and they tend to be like very dark, maybe even like a black color if you get a nice mollisol, but it's mineral. Okay, this is how what I just showed you, these things right here are the soil orders, okay? And this is like the most generalized way of describing your soil. So like I like to say, in Eastern Washington, we have a lot of iridosols, okay? But I mean, that tells us something about them, but not enough. And so from there, we start from a soil order. There's suborders, there's great groups, there's subgroups, there's family and series. And for this class, all I want you to remember is that order is the most generalized way of describing a soil, and a soil series is the most defined way of describing a soil. Okay? Okay, I want you guys to pay attention to this stuff, right? Ist, ent, ept, id, gel, ant, so on. I'm going to show you why this is important in just a minute. Okay, here are some good pictures of some of the soil orders, okay? So let's start with histosol in the top left. What's unique about a histosol, Freddie?
They all have like the organic O side on it.
They have an O horizon, right? And what that means is that this is soil, but it's not like mineral. It's not sand, silt, and clay. It's organic matter. So you're right on. And so we're not surprised to see that we have an O horizon. Okay. AP. Look how black and dark that is. What does OA stand for? Did I talk about that the other day? I think I did. Did I talk about decomposing frogs? In lecture 3, I did. If I didn't, I'll eat my hat. Okay. Anyway, if you need to review that, do it, because I'm pretty sure O and E and I show up on a test somewhere. All right, here's an entisol. Remember, entisol is recent. So up here, we've got a little thin layer of A horizons. This is actually an AP, which stands for a plow layer. So we've probably had someone that's been farming this. And then below that, we're just getting into unconsolidated parent material. Okay, newly formed. An inceptisol, a little bit different in that we got our A horizon, we've got some B development here, and then after that we get into this R, right? Which is regolith, which is the consolidated parent material. So very thin soil. Iridisol, we've all seen this, you know, as you drive down the road and you see like a road cut or something, you might see something like this, very low organic matter, but we do have development of B. We've got a BK horizon and then some C below that. Oh, andisols. These are fun to look at. What do you think this stuff is made up? If this is a volcanic soil, what might these particles be made up of, you guys think? What do you think, Jordan?
I would assume it has high mineral content, but I mean,
You're right.
okay.
What
Yep.
comes out of volcanoes?
Lava.
Lava,
Yeah.
ash.
Yeah.
Okay.
So high
So-
high potassium.
Maybe it depends on what the parent materials are, but yeah, this might be ashy stuff. You know, you guys aren't old enough to remember when Mount St. Helens exploded. I'm barely old enough to. I don't remember it because I was like 6 months old. But when that exploded, the soils near Mount St. Helens are certainly andisols. Okay, and here's a gelosol. Gelosol is a frozen soil, so they've exposed some A horizon here, and there's like an organic layer here, but down here we get into frozen parent material, so it's a gelosol. Okay, vertisol. I need to draw a picture for you guys for just a minute on a vertisol. The cool thing about vertisols is that they tend to like shrink and swell. So here's the soil surface. I'm going to draw a crack right here. And then back to soil surface, and then maybe another crack here. And then soil surface. So what a vertisol is it tends to have a lot of clay particles in it, okay? And it's a specific type of clay particle that has a very high capacity to shrink and swell. And so as these things get wet and dry, hot and cold, they'll shrink and swell, okay? And in the cases where it shrinks, you get these vertical cracks. That's how it gets its name. So here's a vertisol. That's how you remember that. When it dries out, it'll form these cracks. And you guys remember that crap rolls downhill, right? And so what'll happen is you'll get like corners of organic matter and topsoil right here that'll slough off and it'll fall down the pit, okay? And then this thing will get wet, the cracks will go away, it'll squeeze together, it'll dry out, rinse and repeat, okay? This happens over and over and over again over millions of years. And in that process, you get a horizon that was up here. Well, maybe after it's shrinked and swelled, we've got even more A horizon that used to exist up here, and these guys have basically traded places. Okay. Vertisols are very cool because they shrink and swell, stuff sloughs off. It kind of is like a mixing chamber for soil. When I was in graduate school, there's vertisols in Washington. Actually, in Washington State, we have every one of the 12 soil orders except for which one don't we have? We don't have oxasols. So when I was in graduate school, we went to a place outside of Tieton, which is kind of between White Pass and Yakima. And there's an area that has these vertisols in there. And it was a group of graduate students and our professor. And he's like, all right, we're in a vertisol. And one of the grad students, he took a shovel and he put it into the ground. He stepped on it, and the professor's like, all right, be careful with that shovel, because if you use it wrong, it'll break. And as soon as he said that, the student that had jammed it into the ground and tried to dig it up, he snapped the shovel in half because there's so much clay in here. So anyway, good memories of the vertisols. Alpha sols. Okay, again, temperate forest type of situation. And this kind of looks like my alien life form friend, but we've got a horizon with fairly low organic matter. In this case, they're showing an E. Again, E is our zone of eluviation. So we've got something moving out of this horizon. And in this case, it's being deposited down here in a B horizon. And it looks like it's clay particles in this case. So subsoil accumulation of clay. Okay, here's our spodosol. Like I told you, this one exists in like a forest type situation where we've got an O horizon. Okay, we get organic acids that move through here, and we get this zone of eluviation. And down here we get an accumulation of iron and aluminum oxides. That's where we get that red color from. Hey, here's a mollisol, a grassland soil. I don't usually see a lot of E horizons in a mollisol, but in this case, they're showing us one. And again, that's happening for the same reason that it's happening in the spodosol, is that we've got plenty of organic matter up here. We can see it's dark and black. Water's moving stuff down, and it's being deposited down here. Okay, oxisol. This stuff has been oxidized, so iron and aluminum oxide accumulation down here. And here's an ultisol, extremely highly weathered. This one came from North Carolina, so, hot, wet, old soils in that place. I find this confusing, and so you can ignore it. Okay, this is where we get into a little bit of identification. And the only thing that I really want you to remember from here is that when you get like this right here, this Quincy fine sand mixed mesic superactive xeric Torrey cement, that is the identification of a complete soil description. Okay, and the way this works is it starts with series. And I told you just a minute ago that series is the most finite or definitive way that we can describe a soil. So we start with the series, we go through a family, a subgroup, a great group, a suborder, and then an order, okay? And I told you to ignore all this, right? So forget the family, forget the subgroup, forget the great group, forget the suborder, but I want you to remember the order, okay? And so the series is going to show up first, and it does. This is the Quincy Fine Sand series. And the order is going to show up very last, okay? So very last is right here, ent, 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 ent. Where did we hear ent before? Right here, ent. So if we're reading this big long description, Quincy fine sand mixed mesic superactive xeric Torrey cement, I know that this soil is an entisol because of those three little letters right there. Got it? Okay. Now, if you were to look at this one, here's another one. Tatanka, silt loam, fine, smectic, mesic, argiaquic, whatever that means. Okay. Again, the only thing that I want you to remember here is that this is our soil series, Tatanka, and our soil order can be found at the very end. So OLLS. Which one was that? Right here, OL. So this is a mollisol. Have you guys ever seen Dances with Wolves? What? Oh my gosh.
I have. It's a great one.
Who said that? Adil?
Yeah.
Yes. So where was that movie set? Do you remember?
Isn't it? Ah,
It's in the
I
plains,
know where it was.
right? So I think it's like South Dakota or Kansas, somewhere around there. And you guys need to go watch this movie. It's a long movie. It's like 3-hour movie, but it's Kevin Costner, and he gets sent out to this outpost with the military after he makes a really crazy charge during this. I think it's during the Civil War. But anyway, they send him out to this outpost, and he has all these interactions with the Native Americans. And at one point, they're trying to teach him words. And Adil, you'll remember this, that the word for buffalo in Indian, I don't know what language they were speaking, was Tatanka. So where in the heck might we find this soil, given all that information? In the plains, right? And I told you that mollisols are grassland soils that we often find in the plains. Mind blown. Okay. Let's do a little activity here. Wait, let me check my slides, see what we've got. Yeah. Okay, there are hardbound copies of these. I still have a few, but for most people, we use the web soil survey, and that's what the assignment is for tomorrow. And the assignment, it'll like walk you through step by step on how to use the thing. This is kind of how it looks. You can look at the entire US, and let's do this right now. I think we're getting close to the end here. Yeah. So stop share, and let's go here. Great. You can see my Google right now, right? All right. Let's go to soil order descriptions. There we go. That's where I wanted to go. So they name all, like Tatanka and Quincy, right? But like most of these are names that we know, right? Is anyone in the room from Warden? No. I know that Adil's from the Teton Valley, right? Let's put in Teton here just for kicks. Look at that. There's a Teton series. And if we look at the taxonomic classification right here, we've got fine, loamy, mixed, superactic, oostic, haplocriols. Okay. This is our series name. All right, you guys, what soil order do these come from?
Mollisols?
Mollisols. Adil, does that jam with Teton area? Are there grasslands out there?
Uh-huh.
Okay,
Yeah.
wow. Wow, look at that. It's amazing. Okay, let's do another one. Okay, somebody pick a name, maybe like a place. Freddie, pick a name. And it doesn't have to be from around here. You could pick like, I don't know, Maui. I don't know. Pick a name.
I'm kind of interested in like the Pullman area actually. So
Pullman. Let's see if there's a Pullman series. There is. Okay. So this is our series. It's a fine mixed mesic superactive thermic touretic paleostols. You guys are very unoriginal. We're getting the same thing over and over again. What soil order do these come from? Mollisols
Mollisols again.
again,
Yeah.
just like I told you it would, right? Because these are grassland soils. All right. Jordan, pick up a different place, maybe down in Texas.
No,
Or
I'm gonna pick somewhere rocky in Washington. Do Tenasket or Oroville, like somewhere up there.
Tenasket. Coarse loamy, mixed superactive, mollisols. Okay. But yeah, they can be rocky. Let's see. What does it talk about? Does it talk about rocks up here? It tells us these are glacial lake terraces. Okay. 10 inches. Doesn't say anything about rocks.
How about on the coast, like somewhere on the peninsula?
Yeah, let's go out there. Let's try Olympia. Oh yeah, here we go. Olympic series description. We've got a fine mixed active mesic xeric paleohumolts. Olts. So what soil order do those come from? What do you think, Manish? This is an ultisol. Yep. So yeah, those last two or three, sometimes it's two, sometimes it's three or four, they'll tell you what soil order they came from. And on test number one, I know that there's a question that's worth like a buttload of points, where I'm gonna make you match a series description like this to the soil order. And so you're gonna have to look at this and say, okay, blah 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 Olts. Okay, that's an ultisol, and you got to match the two. And every year without fail, somebody misses every one of them. And I do not want that to happen to you guys. Okay. So if this isn't making sense, say something, but it's really that simple. Look for this and look for the soil order that has an Olt in it, and you can't go wrong. Okay, let's get out of the state here a little bit. Let's go to Tampa, Florida. I don't see Tampa on here. Huh. What about Orlando? No Orlando series, for crying out loud.
You spelt it wrong.
Uh-huh. Siliceus hyper blah 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 eps. That's an inceptisol. I'm going to Hawaii tomorrow. Let's look up a Kona soil series. Oh, look at that. I don't know what any of this means. Uic isothermic micro IS. That's a new one, right? What's an IST? Jessica, what do you think?
What's a what again?
IST.
That was I wrote it down. And isn't that the hist oils, the organic, something
Yeah.
like that?
Exactly right. And look at this typical pet on. Kona very cobbly, highly decomposed plant material. Okay, so that's telling us it's gonna be organic. Are you guys picking up what I'm putting down here? Just making sense? Okay. All right. Now that that's done, I want to maybe just give you a very, can you still see my screen? well, I want to give you like a very brief overview of the web soil survey. So just go to whatever browser and type in web soil survey. It'll be the first thing that pops up, and you click on this little green button right here, and it'll start going. One thing that you have to be careful of is let's zoom in here a little bit. So you got all these tools. There's a zoom in, a zoom out, a pan. I don't know what this thing does. And then these AOI, that stands for area of interest. Those are important buttons over there. So let's zoom in a little bit here on Central Washington. Maybe we can find Big Bend. Freda, Wheeler. Big Bend's out by the airport. We all know that. And I think I'd make you do this in the assignment. So go to this AOI thing, and it won't let you choose an area that's too big. So we'll try something that covers a good chunk of campus. And once you've done that, then you can look at all the different stuff. So if you go up here and click on soil map, it'll show you what we've got, okay? And basically, in our area right here, we've got 3 different types of Malaga series. Okay, this is our series is Malaga. And the only thing that differentiates these is kind of how coarse they are. So Malaga here, Malaga here, Malaga here, it's all pretty much the same. But there's just a ton of stuff that you can see. If you go to this Soil Data Explorer, and I like to look at the, they've changed this a little bit. This is dumb. Why'd they change that? Oh, I'm looking in the wrong spot. So once you click on Soil Data Explorer, you can go to, there's this intro, there's a suitabilities and limitations, and then there's the soil properties and qualities. I like to look at this one quite a bit. You can look at some of the soil chemical properties. So let's say that we wanted to look at pH. You click on this pH thing right here, and it's dumb. It makes you tell you how deep you want to look at. So let's look at the 0 to 12-inch range. And then hit this view description thing. Review rating, something like that. Down here at the bottom, it'll tell us this rating right here is basically the answer. So for this Malaga series in our AOI, the typical pH is 7.0. Okay, that's neutral. We're gonna learn about pH later, but anyway, you can look at calcium carbonate, gypsum.
That's pretty
Electrical-
rare around here, yeah. Like usually the soils are a lot more alkaline than 7. Like around here.
You know, I see everything. Like I've seen stuff as low as 6.5, and that's naturally at a 6.5.
Yep.
But you get stuff that goes up into the 8.5 range. It really just depends on where you're at. But yeah, good observation. Let's look at
But never
EC.
acidic, right? In the base, like full acidic. I guess 6.5 is acidic, but never. Do you ever see
Yeah.
anything below 5?
Nope,
Naturally, without
Not naturally.
without ammonium.
Right. So what did I just look at? Electrical conductivity. Zero. Huh. I don't know. This isn't perfect, by the way. But it's cool though, because you can like, if you want to look at your house and stuff and see kind of what some of the soil properties are, this is how you do it.
It's good for looking at land too, like prospect land.
Yeah.
Better than the like thick PDF things that you have to like read through all the series classifications for.
Right. Yeah. So anyway, if with your assignment, you might go find your house and stuff and go play around with this and see some of the things that you can learn, because there's a lot of stuff on here. Shoot, I mean, we could talk about physical properties. If we wanted to look at like organic matter, we can click on that and look at let's just look at the surface layer. And this will tell us we usually have about 0.75% of organic matter. So that's in the same AOI. I've just kind of moved away from it. It's still up in here. So that's your assignment tomorrow, is really to kind of play around with this. I give you some specific things to do, but take the time and do it. It's not too hard. Most everyone that does it gets it all right. So anyway, gosh, we went almost a full hour, you guys. That's a long time. Jordan's already bored out of his mind. He's on his phone. So, all right. Do you guys have any questions before I cut you loose here?
Not right now.
All right. Be looking for an announcement about the upcoming schedule, and I will see you guys live again on the 24th.
I do have a question. So
Yeah.
tomorrow just do the assignment, no class.
That's right. Yeah, it's an online lab. The school's asked me to do online labs.
Okay.
We will meet in person eventually, but for the time being, this one's going to be online. Okay. All right. Peace out. See you guys.
Thank you.
Bye.